say 1 hour. Okay. And stops. Okay. Plot the graph. Getting it? What is the question trying to say? Huh? Is the question
Yes, sir.
clear? Okay. So if we were to draw the graph for this, okay, on the x-axis, what should I plot? Time or distance?
Time, sir.
Time. Good.
So
On the y-axis,
Distance.
distance has to be plotted. Good. And I will take the scale like this: 1, 2, 3, 4, and 5. Okay. 1 square equals to 1 kilometer here. Okay. And 1 square here equals to 1. 1 square here equals to 1 hour, let's say. Getting it? That is 1 hour, that is 2 hour, that is 3 hour. So the vehicle will be traveling a distance, as per the question, it has traveled a distance of how much? 5 kilometer, right? In
Yes,
the
sir.
first hour. So let's draw the perpendicular lines on the time axis and on the distance axis. We have joined that, right? Now the further question says that the vehicle stops. The vehicle is not moving further. Getting it now? So the time will be increasing now. Huh? Time will
Yes,
still
sir.
be increasing while the vehicle will be stopped, while vehicle will be vehicle have a stop after covering a distance of 5 kilometers. So even after 2 hours, it will still be there. Huh, Sundus and Chakrika and Vaika?
Yes, sir.
And again, after 3 hours also, the vehicle will still be standing there, right? Okay. So here we are also getting a line. That is also, in fact, a straight line. Huh? Interestingly, if you were to see this line here, this straight line, is it parallel to the time axis or not? Huh?
It is, sir.
It is parallel to the time axis. So whenever a body has traveled some distance and comes to a position of rest, thereby you will be getting a straight line parallel to the time axis. Getting it?
like this
Mhm.
question like you have to do same like that graph only like in exam if it like ask question.
Hmm. In exam, if such question comes, you have to draw the graph in same manner. Okay, why some examples we will be discussing that. Okay now. So these were now the three shapes of the graphs. Okay. Also remember them. Okay, so a straight line represents a uniform or constant speed. Okay, when the shape of the graph basically gives you a straight line parallel to the time axis, it is a stationary object. Now, sometimes the question might confuse you, like, is the parallel in the case of when the body stops after traveling some distances, the parallel line that you get, the straight line that you get, is it parallel to the x-axis or y-axis? So what will be your answer?
It is parallel to the x-axis.
To the x-axis or to the
Yes.
axis on which you have taken time, right? Okay.
So you gave like that question that
Sir.
it is always coming in like straight line.
A straight line when we talked about, no. In the case of uniform motion, we were saying that the straight line was being drawn from this point O. Huh. So thereby, in that case, we were seeing that the body hasn't stopped now. The body is moving at a constant speed here, right? For 1 minute, the body has traveled, let's say 5 kilometer for 1 hour. For 2 hours, the body has again covered some distance for 10 hours. So the body was in constant motion there now. While here the body has stopped now. The speed here will be, by the way, what would be the speed if you were to find here? Will the body be in speed? No. Since the body is at rest, the speed will also be 0. But if you were to ask, like, after just 1 hour, what was the speed when the body just stopped? Before stopping, the speed was obviously 5 kilometer per hour here. But thereafter, the body, since it came to rest, the speed is 0. The body is as well as rest. Yeah, someone was asking a question. Yes. Yeah. Sundus, you were saying something?
I said that like this question always comes in
Hmm.
straight line.
Yeah, the question of which one? Like a straight uniform motion
This
or non-uniform
question,
motion?
I mean
Hmm.
that the question you gave a body like
Hmm.
that
Yeah,
question
in
always
that
comes
case,
in straight line or no?
exactly. You will always be getting a straight line. You will always be getting a straight line. Looking at the diagram here, you can visualize it now. Hmm. Is there any possible way in which you can get a curved line in the case where the body stops after traveling some distance? No, obviously. Okay.
Sir,
Here also you can see, yes,
uniform motion is when the time changes and the distance will be same, right?
the time changes and the distance will be same. No, look, the thing is now the time
No, sir, not in the
increases.
graph, like actually.
Mhm. The time increases. Okay, now.
And the distance
And,
remains same.
and the distance traveled in a specific amount of time, it remains same. For
Okay.
example, I am traveling to somewhere and say that I have traveled at, um, let's say, I have traveled, let's say, 100 kilometer. Okay. And let's say this took me 5 hours to complete. This journey took me 5 hours to complete. Okay. So in order to find out my speed, what I did now, I simply did what? I divided my journey into 5 parts, let's say 1, 2, 3, 4, and 5. Okay. Okay, there's one more. 5 parts. So I would have checked my watch at regular intervals. So what I would have done, let's say, I know that my journey is going to be in 100 kilometer. So what I did, I can do one thing that, let's say, in 1 hour, how much of distance I have traveled here. In the second hour also, I would have checked that how much of distance I have traveled. Once the 1 hour ends, I will set a timer for another 60 minutes for another 1 hour. So thereby, if I'm observing that I am covering 20 kilometer in each 1 hour, then thereby I am seeing that my speed is constant now. Yeah, my speed will be constant here now, guys. You guys know speed equals to distance upon time. So in each of the cases, the speed is going to be
Yes,
20
sir.
upon one here. So that is going to be 20 kilometer per hour. Here also 20 kilometer per hour. Here also, and here also, and here also. Yeah, 20 plus 20 plus 20 plus 20 plus 20. That is 100 kilometer
Yes, sir.
right now. So the time will obviously be increasing, but in equal amount of time, equal amount of distance is being traveled. In the first 1 hour also, you have traveled 20 kilometer. In the second hour also, you have traveled 20 kilometer. Suppose if you were to accelerate, if the vehicle were to be accelerate, then in the second hour, if the body, let's say, covers 30 kilometer, okay, then the body decelerates back to 20 kilometer. Hmm? The vehicle slows down to 20 kilometer per hour then. So here you are seeing that you are keeping the time same, but then the speed reduces. Okay. So the distance is also, the distance covered will also be less here. So the thing is that, keep it simple, that in uniform motion, we travel equal amount of distance in equal interval of time, as I gave you just an example here. Is it clear?
Yes, sir, it's clear.
Sir, I
Okay now.
didn't understand. Can you explain again?
Yeah, sure. Look here, Sundus. I just said that if you were to travel a distance of 100 kilometer, right, and in each 1 hour, you are traveling exactly 20 kilometer, right now. So in that case, you will see that it means if in 1 kilometer, you're traveling exactly 20 kilometer, it means your speed must have remained same throughout the journey. Yeah, that's why you are not covering an equal amount of distances now. Hmm. Like, say, if you were to go to your school from your home on an empty road where there's no traffic, okay, so you will be traveling, let's say, for 5 minutes to your school, let's say 2 kilometer, let's say, okay, or let's say 10 in 10 minutes, we'll be traveling 2 kilometers. Okay, where do you will be applying? Let's say you applied no brakes, so you travel straight 2 kilometers in 10 minutes. Getting it now? And let's suppose then again you further travel a distance of 2 kilometer, stopping nowhere again in 10 minutes. Suppose you didn't stop at the school, then you again covered another distance of 2 kilometer again in 10 minutes only. So there where you're seeing that you have covered equal distance of 2 kilometers in the same time of 10 minutes in each cases. If you were to divide your whole journey into two parts. Yes. Am I getting into your head? Is it being clear? Hmm? Yeah. Sundus? Chakrika, Vaiga? Okay, na?
Yes.
Okay. If it's clear, I suppose we shall be moving ahead then. Okay. Also, few more important things. Like, whenever you see a graph like this, where you're getting a curve like line like this. So this curve line, you guys know, it represents nothing but the speed, right? It represents nothing but the speed of the vehicle. So if it is in this manner, the curve is upwards in this manner, then the speed is increasing. Getting it now?
Like does not all lines like all like that lines represent speed.
Mm-hmm. No, all the line represents the speed. Whether we talk about this curve line or whether we talk about the straight line, okay, now, or whether you talk about this line also, okay, where you are having the parallel line parallel to the time axis. So there also the slope, you know, these lines are basically has been called as slopes. In mathematics, you will get to learn the line which is drawn in the graph, okay, between the two axes, okay, that has been called as slope. So all the slopes, whether you have got this slope or this slope or this slope, all of them represents the speed whenever you be plotting a graph between distance and time, because speed is equal to distance upon time. Yeah. Okay now. So
So you
back
are
to
saying that this line only represent like the speed is increasing.
Mhm. I'm saying in this case, I'm saying in the curve line. Okay now. While if, first let's talk about this one. So if the curved line is in this manner that it is bending upwards, yes, Vaiga and Chakrika, if you were to see that the curved line is moving in this manner upward, so then we will see that the speed is increasing.
Okay, sir.
Okay now. So
Yes,
we
sir.
can do it using one example as well. Yeah. Say this is again 5, 10,
Sir,
20. Mm-hmm.
before did you say that like I'm just keep on getting confused because I
Mm-hmm.
think you wrote the time same and then the distance also same for uniform motion.
Hmm.
But then the time changes and the distance remains same, right? Like the speed. I mean, distance.
Mm-hmm. Okay, look here. The thing is now that your basic confusion is that regarding like the definition of uniform motion, that like whether it's the same distance travel in same amount of time, or whether the time also increases, so same distance is being traveled. Is that the confusion?
Yes, sir.
Okay, look, the thing is basically now, if you were to talk about uniform motion, so in the case of uniform motion, you see in everyday life you are seeing that objects are traveling at different speeds. Hmm. Like if you were to keep your journey throughout the journey same, if you were to keep your speed same, hmm, without applying any brakes, or like suppose someone is traveling at a speed of 60 kilometer per hour, hmm, without applying any brakes. Let's say there is no traffic, no brakes has been applied. So that person, if he or she took, let's say, 5 hours to cover that 30 kilometer of journey without applying any brakes, without any hindrance, without slowing down. So in that case, we see that the speed has been same throughout the journey, right now. So if the speed of an object moving along a straight line, remember we are talking about a straight line, not a curved line. If the pathway is curved, obviously the speed cannot remain same. The person has to apply brake. So if the speed of a body remains same throughout the journey in a straight line, then it is said to be uniform motion. In simple terms, we have put it like that. Now,
So
where
both of the situations can be counted as uniform motion, right?
when you say both, what do you actually mean?
So both in the sense, like just now you said, right, without like taking any
Hmm.
breaks, without
Hmm.
stopping the vehicle.
Hmm.
So like
Yes,
that,
that is the thing. Yes.
like so we can consider both the situations as uniform motion, right?
Yeah, exactly. We can consider that situation as a uniform motion. For a body to be in uniform motion, certain conditions are required. The conditions are
Okay,
what?
sir.
First condition is that it has to be a straight path. Because if the pathway is curved like this, the person will have to apply whenever he takes a turn, right? So that
He
is
have
not
to apply
possible.
different
Hmm.
speed.
Yeah. Then the speed will be changing here now, right? If the curve is more
Okay,
steep,
sir.
then the speed will be lesser. So if the body is traveling in a straight line without having applied any brakes, then the body will be doing a uniform motion, right? For uniform motion, as several times you have discussed that no matter what distance you have traveled, if you were to divide it into parts, you will be seeing that in equal portion of time, equal distance is being traveled by the body. Getting it now?
Yes, sir. I get it.
Okay, getting it. Good. Now, back to what I was saying that if you were to see a graph like this, it's actually a graph of what, by the way? Uniform of non-uniform motion?
Non-uniform motion, sir.
Non-uniform motion.
Non-uniform.
Non-uniform motion. So thereby you will see that the curve is towards upward and hence the speed of the body will be increasing. Let's say you have taken some example. For example, again, let's take a speed of say 5, 15, 35, 75. Okay. Okay. See, this is where you have added it. Now look at this line here. And you guys are required to find what? Find the speed. Okay. So I'm assigning you. Sundus, you find the speed of the body at this point 1. Vaiga, you find the speed of the body at this point 2. And Chakrika, you find the speed of the body at this point 3. Okay now. And
Yes,
then
sir.
again, Sundus, you will be required to find the speed of the body at point 4. Do it quickly. You guys know the formula of speed is equal to distance upon time. So for each point, you will be dividing the distance and time. Okay.
Now, what's the unit?
Yes. Okay.
What's the
Unit.
unit?
Yeah. You take it to be kilometer here and take it here in minutes. Or do one thing, just take it in hour. Keep it in the standard format. Although it is not possible, like to take what it would be taking 5 hours to cover a distance of 5 kilometers, but still we are just solving questions here. Just quickly.
Done, sir.
So what is the speed of the body at point 2, or where the question to you was at point 3?
No, sir, for like 0.2.
What is the speed here
1.5
for point number 3?
is 4.22.
Point 2, no? Yeah, it's
Yes, sir.
1.5. Good. 1.5 kilometer per hour. Okay, not just 1.5. Yeah, Sundus, quick. At point 1, what is the speed of the body?
1 kilometer. Sure.
Chakrika?
So 1.1, or should I still need to exceed it?
35 upon 20. Okay, you have
Sir,
said
isn't
1
it
point.
25 point? Oh, shoot. Sir, I did 25 on 30,
No,
sir. So,
it's
so
actually
can I ask more
35.
time?
Yeah, okay, sure. Yeah,
Thank you.
Sundus, what about you, dear? Have you got the speed?
Getting in decimal, so the last one.
Sundus, why would you be getting it in decimal? I've asked for first one, not first one.
The first one is 1 kilometer per 1 hour.
Okay, yeah, 1 kilometer per hour.
I was
Then
talking about the second one, sir.
no,
Like
no,
the 75 by
second one,
40.
no, that was
No,
already
I'm
assigned
talking
to
about.
Yogika.
No, I
Fourth
was
one.
talking about my 75 by 40. That one I was getting in decimal.
Okay, that one you will be getting in decimal, obviously. क्या है आपका value? What is the value you are getting?
Sir, I got my value also.
That is Vaiga, how much? Chakrika?
Sir, it is 1.75.
1.75 kilometer per hour. Good.
So the last one I got 1.875.
1.875. 875 kilometer per hour. Okay. Well done, guys. Okay, now you guys tell me, is the speed of the body here increasing or decreasing? And also look at the shape of the slope here.
Sir, it's
So it's
increasing.
Obviously, it's increasing now from 1 kilometer to 1.5, then to 1.75, and then to 1.875 kilometer per hour. So this graph will show you, whenever you have got this graph, you will obviously say that the speed of the body is increasing, right? Okay. As the graph becomes more curved, if you are having two slopes for distance time graph, if you are provided with two slopes, slope number 1 and slope number 2, right? So this is 1, this is number 2. So in which slope represents the more in speed? Which slope represents the more speed? Slope number 1 or 2? Slope number
Sir, 2.
2 will be representing more speed, right? As the slope is more curved and more tilted towards the y-axis or the distance axis here, that will be representing more speed. Getting it, guys? Sundus, Chakrika, and Vaiga.
Yes.
Okay.
Yes, sir.
Okay,
Yes.
then now, what if the graph is like this now? What if the graph is like this? What does it represents? If the graph were to be like this,
Sir, it's non-uniform.
that is obviously non-uniform. Talking about whether the speed of the body is increasing or decreasing.
They're decreasing.
Sir, it's
Decreasing. Exactly. So thereby you will see that the speed of the body is decreasing. Getting it now? Okay. So from the given diagram also you can understand it, right? Also, interestingly, look at this red slope here. So here the body was moving at a steady speed, at a constant speed, right? Thereby the body stopped here. So it's at a stationary state, not moving at all. After having stopped for some time, then it started to again move, right? But the speed again started to slow down, not increase down. But also here you see that speed has, although it came down, but it's same here as well, because you are getting a straight line. So here also there will be a steady speed. Yeah. So for the uniform motion, the graph can be like this also, where the body has been continuously moving up. Okay, moving, as you can see this slope here. While if the body stops after some time and then again it starts to move, but the speed of the body reduces, then the graph will not go up, the graph will come down. Getting it, guys? The body slows down here. Yeah, Sundus, are you getting it? Okay,
Yes,
let's do some questions and then the things will be getting clear then. Okay. By the way, which graph represents more speed? Graph number B or graph number A? Slope number B or slope number A? A represents more speed, obviously.
A.
So speed of slope A is more than speed of slope B. Getting it. Good. Now, question number 1. Read the question. Why can read the question? What does the question says?
Okay, sir. Choose yes or no. Can the distance time graph be used to represent the non-uniform motion of the body?
What do you guys think? Can it be used?
Sir, yes, sir, yes.
Obviously, it can be used. Right now, Chakrika answer on this.
Yes, sir.
Next question, Chakrika. Which among the following graphs is not possible?
Sir, time graph.
Exactly. Because we plot a graph between two different quantities, not two same quantities.
Yes, sir.
Okay, Sandosh, you see question number 3. What does the question says?
In a distance time graph, which variable is plotted on the y-axis? Distance, sir.
Distance, good. Okay, then again, Vaiga, question number 4.
Yes, sir. So, like the below graph represents a distance time graph with uniform or non-uniform velocity. It's uniform motion, sir.
It's a uniform motion, good then. Okay, again, Chakrika, look at this question.
Yes, sir. Which of the following options represent the distance time graph of a stationary object? Sir, distance time graph D, sir.
Distance time graph D.
D.
Very good. Very good. Okay. Also, you guys are required to keep your cameras on in the class. Okay, now. I have been repeatedly asked the students to keep their cameras on in the class. That's why I have been saying this multiple times. Okay. Now coming back to you, Sundus. Now question number 6. What does the slope of a distance time graph represents?
Speed.
Speed. Okay. So speed, it represents speed also, or exchangeably, velocity has also been used for speed. In the later class, you will get to know that units are of two types. One is the vector unit, one is the scalar unit, right? For example, if I were to say 1 kilogram or 1 liter, getting it now? So thereby, do you get any idea of direction? Like, does weight or mass has got any direction? Does 1 liter has any direction? No, it doesn't. When you hear of these quantities, you don't think of any direction, like 1 kilogram south, 1 kilogram north. Do we hear it like that?
No, sir.
Obviously, no. But
No,
if
sir.
I were to say that 30 kilometer per hour north, the wind has been blowing at a speed of 30 kilometer per hour in the north direction, right? Or you are moving towards the southeast direction with a speed of 80 kilometer per hour. You are moving towards the southeast direction. So thereby you are getting a idea about the direction also in which the quantity is working, where you are moving. So the quantities are of basically two types. One which has got direction also, and the another one that is directionless, that has been called as scalar quantity. So if I were to just say that I am moving with a speed of, let's say, 30 kilometer per hour, but if I were to say that I am moving with a speed of 30 kilometer per hour in the south direction, thereby I have included direction also. So in that case, speed will not only be called speed, but it will now be called as velocity. Getting it?
So can you repeat one more time?
I just said that if I am simply moving somewhere, okay, I'm saying that I'm moving with a speed of, let's say, 30 kilometer per hour. But if I were to be very specific and I'm saying that I am moving towards the north direction, okay, now with a speed of 30 kilometer per hour. So thereby, apart from just normal speed, I have also specified the direction in which I am moving. So then speed is called as what? Speed plus direction, then it will be called as velocity.
Oh, okay, sir.
Am I clear now?
Yes, sir.
Okay. So Sundus, Chakrika and Vaiga, you can say both velocity and speed will be correct here, right? Okay. But
Yes, sir.
as of now, you have to take on speed only. Okay. If the option is not given like both A and B, then you can just take on a speed. Motion of the blades of a ceiling fan represents which type of motion? Vaiga?
So circular motion.
Circular motion. Good. Hmm. Here's a good question here. It is to all three of you. One of you, please read the question.
Two students were asked to plot a distance time graph for the motion described by table A and table B.
Okay. Have a look at the table A and B. You have to show like this figure drawn here, this graph drawn here. It is correct for table number A or table number B. So first we will try to understand the graph. Like in the graph, what type of motion has been represented? What do you guys think? Is it like uniform, non-uniform, or the
It's
body is not moving?
So it's a uniform motion.
It's a uniform motion. Now, if you know that it's uniform motion, now you need to recall that a uniform motion, what are the characteristics of a uniform motion?
The table B is the correct answer.
Table B. Okay, we will come to that. But first answer my question that for a body to be in uniform motion, what are the conditions required?
It should be in like straight line, the is the
Hmm.
answer. And
Okay. Then
the distance remains same, but then the time changes.
no, you're again like the distance remains same. No. If you were to answer in that manner, no, then it will be becoming confusing now. Like when I say that the distance remains same, but the time keeps increasing. So that actually shows that the body has came to a stop now. Huh, Chakrika? Like the distance remains same. Like I have traveled the distance of 5 kilometer. I have traveled a distance of 36 kilometer. The distance remains same. Okay. But the time keeps increasing. It means that I have covered that much distance and now I have came to stop now. I have stopped my vehicle. So the time keeps increasing. So if you were to answer like that, if you were to define it in that manner, then it will be of definition of a stationary body. Like the body has traveled some
So
distance, now it has stopped. So
okay,
we
so
see that say that the body is traveling with a constant speed and in which the body has traveled equal distances in equal interval of time. Chakrika, say after me. In uniform motion, a body travels with a constant speed and travels equal distances in an equal interval of time. Say it one more time. Say it once.
in uniform motion, the vehicle or the body travels in a equal distance of time. I mean, in equal distance and in equal time. Like
Equal
in
intervals of time.
yes, sir. Equal intervals in time.
Okay. Now that is one thing. Also, I added one more thing in there that the body travels with a constant speed or same in speed. Getting it now? And you know, distance time graph basically gives you the speed now. So you will try to find the speed for table number A and table number B. For the data is given here, try to find the speed. So in whichever table you get the constant speed, that will be representing the uniform motion.
Table
Yeah, I am saying that for a body to be in uniform motion, you know that its speed has to be same. It should not be changing, right?
So table A.
Table A. Okay, let's check that.
Yes, sir. It's table A.
So
So
here,
when we divide 10 by 2, it's 5. When we divide 20 by 4, it's 5. When we divide 30 by 6, it's 5. When we divide 40 by 8, it's 5. And when we divide 50 by 10, it's 5. So it's the speed is not changing. So,
exactly. So 5 meters per minute. But in the second case, you're getting 5 and then 5, then 5. But here you're getting how much? 4, 5, 5. Okay, let's quickly check that as well. In the second one also, you are getting the same now. Yes?
So
Yeah. For the table number B also, we can't ignore the table number B as well. So there, in
so
that
it's
case
like
also,
both A and B.
both A and B. Okay. So the option given, option number A is Santosh in the beginning said that table number B
Yeah,
represents
sir. Then
uniform
I
motion.
think it was A because I didn't figure
Hmm.
it out. And I actually
Hmm.
zoom it, then I understand.
Yeah, whenever there's an option given like both, then you should check the both data, like the whatever data are given in the question. So option A number A is the correct one here. Now, second question here. Okay, Chakrika, will you please read the question?
Bojo goes to the football ground to play football. The distance time graph of his journey from his home to the football ground is given as figure. So shall I also read the questions like ABC? Okay, sir. What does the graph between point B and point C indicate about the motion of Bijo?
Okay, answer this one. Yes. What do you guys think? Or Chakrika, first you try to answer this one. Then the second question will be to Santosh, and the third question will be to Vaiga.
Okay, sir.
Okay.
So like we have to say what motion is it in, right?
Here
So
it's indicating like
stationary.
what type of motion, like is the body
So it's
moving
stationary.
or not moving, or like what? It's stationary, exactly, because it's giving you a line parallel to the x-axis or the time axis. So good. Okay, next question is to Sundus, I guess, right? Read the question, Sundus.
Is the motion between 0 to 4 minutes uniform or non-uniform motion? So I think it's non-uniform motion.
It's non-uniform motion. Good. Why? Because if you were to look at this point here, from here the line has broken and it has moved slightly in this direction. Yeah, it's not continuous. Just before the 4 minute, the body has increased its speed slightly. Yeah, if you to see from here to here, the speed has been constant, but here the speed has little bit increased. You guys know the it's like this here, like this. Getting it? Yeah. Had the graph been like this all throughout the journey, okay, from 0 to 4 minutes, then it would have been an example of uniform motion. Getting it now, all three of you?
Yes, sir.
Yes,
Okay,
sir.
now. So that's a case of non-uniform motion. Okay, question number C, Vaiga.
Yes, sir. What is his speed between 8 and 12 minutes of his journey?
So you know the
So one
formula of speed.
so like 150 divided by 8.
150 divided by 8. Why would you divide it like by 8? I have written here total distance upon total time here. Now, if you guys were to look here.
So like, will it be like 150 and 10? Like 10 will be in the middle.
Look here. Okay, look here. If you
Is it
guys were to,
300
yes.
by 20? 300 by 20?
No. Look here. If you were to count the distance here, look at the distance here that the body has traveled or Pooja has traveled between 8 and 12 minutes. So at the 8 minute, how much of distance she has traveled? 150 meter. So at this time, the body has traveled 150 meter, and at the end of 12 minutes, he has traveled 225 meter. Yeah. If the
Yes.
questions are, if the texts are not visible, no, please do let me know. I would zoom the question. So here, if you were to find the total distance,
So like will it be, the answer would be like 18.75?
18.75. I believe that is correct. Okay,
So,
no, but
but then
let's. Mhm.
so but then 18.75 is only for 50 divided by 8, right?
50 divided by 8
50.
now.
Yes, sir.
No,
So
no,
like,
no.
so because like 225 minus 150 is equal to 75, and 12 minus
Upon.
8 is equal to, yeah, 4.
Exactly. Exactly. That's what you guys are required to do. Total distance from here to here will be 225 minus 150 now. You're getting it now. And total time will not be 8 now. Total time here, it's 4 minutes and 4 minutes. Sorry, it's 2 minutes and 2 minutes here. So that is 4 minutes now. The total time will be 12 minus 8 minutes. That is 4 minutes. Are you guys getting it? So in that manner, we can calculate the speed. So total distance is 75. Total time is 4 minutes. So that will be 18.75 meter per minute. Yeah. Santosh, Chakrika, and Vaiga, is that clear to all three of you? Someone, by the way,
Yes,
answered 18.75. That is correct.
I answered.
Yeah, very good.
How can you explain again? I didn't get it.
Mhm.
When
Okay.
I did 150 divided by 8 and I got 18.75.
150 divided by 8 and you got
18.75.
18.75. Yeah, look, the answer is correct, but the method is wrong here now. Okay, the method is wrong. Let me explain again. When you calculate speed in this case, you will be finding the total distance and then dividing it with the total time taken by the body to cover the distance, right? So total distance is this much now. The distance between here and here. So here the body traveled 150 meter and here the body has traveled 225 meter. So the total distance is not 150 now. The difference between 225 and 150 meter would be the actual distance traveled by the body now. Getting it, Chakrika? Like
Yes,
if you have
okay.
traveled, let's say if you have traveled to a shop that is 1 kilometer away from your home and you are now traveling to your school, now that school is away for like let's say here it's 2 kilometer. Okay, now you have traveled to a shop that is 2 kilometer away from your home. Now you are traveling to a school that is, let's say, 8 kilometers away from you, from the shop. That means 10 kilometer. So the distance between your school and the shop would be 10 minus 8 and that would be 10 kilometer, 8 kilometer. Same is the case here. So the total distance would be 225 minus 150, that would be 75, and total time would be the time here and here. Subtract them, that would be 4, that is 18.75 meter per minute. Clear?
Yes, sir.
Okay, good. Now one more question is there. You guys are not getting bored now?
So can you just go back to the before question once?
Sure. Yeah. Yes,
Yes,
Chakrika. Okay. Now moving on. Look at this question here. Here you have got the distance time graph of the motion of an object. Okay. The questions here are very simple. What will be the position of the object at 20 seconds? Yeah. By position, it simply means how much of distance the body would have traveled at the end of 20 seconds. Yes.
So can I do?
Yeah.
8.
8 meter.
Yes, 8 meter.
8 meter. Good. Chakrika, what will be the distance traveled by the object in 2 whole seconds?
So 6 meter.
6 meter. Good. Sandus, what is the average speed of the object? Average speed, total distance traveled by total time. Getting it now? So you need to see the total distance the body has traveled here and the total, how much of total time was taken to cover that distance. Yes, Sundus, are you there?
I'm there, sir, but I'm
Yeah.
not understanding the question.
Look here. We know that average speed is what? Average speed is nothing but the speed of the body throughout the journey. So here you see the although the speed is not constant now. Like the speed here was something else, here something else, and there's something else, right? Because it's not a case of uniform motion, it's a non-uniform motion. So you need to find what? There are two ways to find the average speed, if you guys remember. Average speed can be found out in two manners. One is you take out the total distance, okay, and then divide it with the total time taken, right? Or another method is like this. If the body had three different speeds, let's say, or four different speeds while the body was traveling to some place. For example, the body for some part of the journey, let's say from here to here, the body travel at a speed of, let's say, 10 kilometer per hour. Then it travel at a speed of 20 kilometer per hour. Then it travel at a speed of 30 kilometer per hour. And then again back it travel to at a speed of 5 kilometer per hour. So here, what you guys will be doing, you will simply add all the speeds, 20 plus 10, 30, 30 plus 30, 60 plus 65, and then divide it with what? 4. Divide it with 4. So 16 point something would be the average speed of this body during the journey. That was another method. But here you will be using the first method to find the average speed. So total distance, if you were to see the body, since here the time limit is up to 20 seconds only. Okay now. So during the time of 20 seconds, the body has traveled a distance of 8 meter as given in the graph. Yeah. Further data has not been mentioned in the graph. Getting it, Sundus, Chakrika, and Vaiga? Are you guys getting it?
Yes, sir.
So total distance is obviously given here. So that is 8 meter. And the total time is 20 seconds now. 20 seconds here. Yeah.
It will be
0.4 meter per second. That has been the average speed. Getting it now? Or what else you guys could have done? You could have divided these two also. Here you will be getting separate speed at 0.1, 0.2, 0.3, and 0.4. You will be getting separate speeds. Then add them and then divide them by 4. You will be getting your answer in that manner also. Yes. Okay, so here let's say the speed will be
the first method again.
This one.
Yes, sir.
Okay, look here. In the graph, how much of distance we can see the body has traveled? As per the graph, where does the slope ends? The slope ends here now. The slope has ended here now.
Yes, sir.
So that the point where the slope ends, it shows the total distance traveled by the body. Okay. And this point corresponds to what time in the x-axis? It corresponds to
20.
the 20. So that means 20 minutes was the total time taken to travel to this distance of 8 meter. Getting it now? So that's
Okay.
these are basically your total distance and total time given in the question. Okay. Second method was to find individual speed at each point. Okay now. So that's a bit a lengthy task. We could do that as well, but there could be some errors in developing that. Okay. You might be having errors because here also, if you to see, the line has bent here and we are not sure at what point the line has bent, at what time the speed has reduced here.
Okay, sir.
Okay now. So this is how we are required to solve such questions. One more question is there. Let's quickly get done with this one also. A bus is traveling at a speed of 54 kilometer in 90 minutes. The speed of the bus is. Yes, all three of you try it quickly. And take care of the unit. Okay now. Like if the answer is in meter per second, so you would be required to convert this kilometer and then minute into meter and second. Okay. Okay. Solve it quickly. Yes. Done.
Sir, done.
Good.
Done, sir.
Sir,
Yes.
the
What is the answer?
first one is correct
So the
answer.
first one is
0.6 meter per second.
You all three are getting first one, no?
Yes, sir.
Yes, sir.
All right, then. Very good. Okay, guys, then. So that's it for today. Okay, by the way, the chapter has not been finished because we still have got to cover the next part of the chapter, that is time. Okay.
Yes, sir. Like the sundial clock.
These tools we will be discussing about. Okay, now. So in the next class, we will probably try to cover the chapter. Okay.
Okay,
and
sir.
keep revising whatever we have discussed so far.
Okay, sir.
Okay, sir.
Okay, then, guys. Bye.
Thank you,
Thank
sir.
you.
Bye.